Hello, everybody. Today we are going to learn a new topic. It's called vision and brightness. But before we continue with our lesson, we have some new vocabularies to learn. First, vision. Again, vision. Let's spell vision. 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 Next word, transparent. Again, transparent. Let's spell transparent. 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 Last word, surface. Again, surface. Let's spell surface. 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 Now let's proceed to our topic for today. It's vision and brightness. Imagine yourself without eyes. You can't see. Everything will be dark. Life will be difficult. Your eyes allow you to sense light. You see objects when a process occurs that involves both your eyes and brain. Light enters the eyes through the transparent front surface called the cornea. The cornea protects the eye. It also acts as a lens to help focus light rays. But what is a cornea? Let's see this video.
Cornea. The sclera has a transparent circular segment that bulges out at the front to let the light in. This is the cornea, which bends the incoming light and directs it towards the center of the eye. The bulging shape of the cornea is the precise curve which flattens out at the edges to minimize aberrations that would otherwise distort the image. The cornea is appeared half a millimeter in thickness, and it provides 2/3 of the focusing power of the eye and is a powerful refracting surface. The cornea is the most important layer in the refractive procedure, which in tandem with the lens forms a clear image on the back of the retina. It is extremely sensitive with more nerve endings in it than anywhere else in the body. The cornea is also a living tissue, and this eye will work properly. It has to have a continuous supply of oxygen and nutrients. Other body tissues obtain this vital requirement through the blood. But in the cornea, blood vessels would interfere with the passage of light. So, instead, it gets most of its oxygen directly from the air, absorbing it through the tears. Nourishment comes via the aqueous humor of watery transparent fluid that fills the space between the cornea.
After passing through the cornea, light enters the pupil, the part of the eye that looks black. The pupil is an opening through which light actually retina enters the interior of the eye. In dim light, the pupil becomes larger to allow more light to come in. In bright light, the pupil becomes smaller to allow less light in. Now, what is a pupil?
The pupil is a hole located in the center of the iris of the eye, allowing light to strike the retina. It appears black because light rays entering the pupil are absorbed by the tissues inside the eye. The iris controls the amount of light that enters the pupil by using special muscles, constricting to decrease light and dilating to allow more in. This behavior explains why the pupil increases in size when it is subjected to dark environments and decreases in brighter ones. The normal pupil size ranges between 2.5 to 4.0 millimeters, however, it can approach a maximum size of 3 to 8 millimeters. The pupil plays a vital role in our ability to see, behaving similarly to a camera's aperture, allowing images to be seen and captured.
Now this is an illustration of the visual system. As you can see, this is the cornea, this is the retina, here's the iris, and this is actually the eyeball, and this is the brain. Okay, it says here the optical system and the perceptual system. Next, here is the eye and the brain. Okay, the object that comes through the eye must go to the brain as well to process the image. Here's another figure, 6.14, the point of vision. Okay, normal sight with normal sight. After entering the pupil, the light goes through the lens. The lens of the eye is a convex one, refracting light to form an image on the back of the interior of the eyeball onto the retina. When the cornea and lens refract light, an upside-down image is projected onto the retina. The retina is an organ at the back of the interior of the eye, which is made of photoreceptor cells. These photoreceptor or light-sensing cells are called rods and cones and transmit the projected image to the optic nerve connected to the eye and onto the brain. This is how our eyes work.
Vision is the dominant sense for most people with sight. The organ of sight is the eye. Think of it as a slightly irregular, hollow sphere that takes in light and translates it into images. If we enlarge the eye and look inside it, we can discover how that's done. Inside the eye are various structures working together to create an image the brain can understand. Among these are the cornea, a clear dome-like structure covering the iris or colored part of the eye, the lens directly below it, and the retina, which lines the back of the eye. The retina consists of thin layers of light-sensitive tissue. This candle can help us understand how the eye captures images and then sends them to the brain. First, the candlelight passes through the cornea. As it does, it's bent or refracted onto the lens. As the light passes through the lens, it's bent a second time. Finally, it arrives at the retina, where an image is formed. This double bending, though, has reversed the image and turned it upside down. If that was the end of the story, the world would always appear upside down. Fortunately, the image is turned right side up in the brain. Before that can happen, the image needs to travel as impulses along the optic nerve and enter the brain's occipital lobe. When the image forms there, it regains its proper perspective. Now let's consider two common conditions that cause blurry vision. The eye's shape is important for keeping things in focus. With normal vision, light focuses precisely on the retina at a location called the focal point. But what happens if the eye is longer than normal? The longer the eye, the more distance there is between the lens and the retina. But the cornea and lens still bend light the same way. That means the focal point will be somewhere in front of the retina rather than on it. This makes it difficult to see things that are far away. A person with a long eye is said to be nearsighted. Glasses with concave lenses can correct nearsightedness. The lens widens the plane of light coming through the cornea. That pushes the focal point back onto the retina. Farsightedness is just the opposite. The eye's length is too short. When that happens, the focal point is behind the retina, so it's difficult to see things that are up close. Glasses with convex lenses narrow the plane of light. Narrowing the light passing through the cornea moves the focal point back onto the retina and can correct farsightedness.
Okay, it's time for review. Let's see what you have learned so far. You see objects when a process occurs that involves both your eyes and brain. Light enters the eyes through the transparent front surface called the cornea. The lens of the eye is a convex one, refracting light to form an image on the back of the interior of the eyeball into the retina. The retina is an organ at the back of the interior of the eye, which is made of photoreceptor cells. Photoreceptor or light-sensing cells are called rods and cones. Now for our activity, draw the human eye and label each part. Again, draw the human eye and label each part. Here's an example. You get it? Now that wraps up our lesson for today. Hope you liked the lesson, and thanks for watching. See you on the next video.